In this video, we're going to trace through our recursive solution for the factorial function, and we're going to look behind the scenes about what's going on kind of as the computer's processing our method calls. So we already created our code in the previous video. We ran it. Things were good. So one way to see kind of more what's happening behind the scenes is to use the debuggers. I'm going to set a breakpoint right here at the first line in my factorial method, so that as I'm running, it'll stop there and allow me to step through the code line by line. In addition to that, I'm also going to create this paper trace of the method calls that are made using a call stack. You've probably heard of a call stack. We talked about that when we were doing exception handling, and you might remember if an exception gets generated and Java prints a exception message at runtime, it prints the call stack trace. It prints the trace of all the methods that have been called leading up to the problem. So we're going to do the same thing. We're going to keep track of the call stack, which just means the order of the methods that have been processed as Java's running your program. And you can think of it kind of like it's a giant chute that you can drop stuff into. So as we drop in method calls, they're going to sink to the bottom to the next open space. And then as methods finish, we're going to pop them off the stack, which means we'll remove them from that chute. So as we add things, we're going to drop them in until they kind of like hit the first open space. And then as we process things, we're going to remove them out of the stack to indicate the fact that they've been processed. I think you'll catch on as we start tracing through our code. So let's look at the main program first, because that's where the first method call gets generated. So we're going to set up our scanner. We declare this variable number. Say enter a positive integer. We read the value of number. Check to make sure it's positive. Let's say they call it with the value 4, so number equals 4. I'll add that to my list of information here. In my main program, number equals 4. And then we finally get to the method call where we say print out the factorial of blah, 4 is, and then we call factorial of 4. And so the first thing that's going to happen is we're going to include this factorial with the argument 4 into our call stack trace. Factorial 4, and that's just going to drop all the way down to the bottom because that's the first of the method calls. And then we know as soon as we call the method, it's going to transition over to the method code. In this case, it's going to set up our parameter number. So we keep track of the value of number that's local to this method call. It's 4, because that's the value of the argument that gets passed in. All right, cool. So at that point, that's where our debugger is going to pick up and help us out a little bit. Let's run our program using the debugger. So this is just catching us up with where we are. So I entered the value 4, and now it's taken us into our method call. The first thing it does is set temp equal to 1. So inside this method, temp is going to be equal to 1. And then we're going to print out in the recursive call, number is currently, and then it's going to print the 4. So if I execute the next step and I look at the console, it should print that. Maybe I'm like 1 ahead. Print that out. Yeah, I'm 1 ahead. So if I switch over to the console, it's now printed out that line in the recursive call, number is currently 4. Awesome. And now I'm doing my test. I'm checking to see if number is less than or equal to 1. Number right now has the value 4, so that's not less than or equal to 1. It should move to the else case, which it does. And now it's creating a new value for temp. It's saying make temp equal to the value number, which is 4, times, and then it's making a call to factorial of 3, because number is currently 4, so number minus 1 is going to be 3. So it's getting set up for that next method call. So when we execute this line, we'll see that it comes back around to the factorial function again, starting up at the top. That's because it just called factorial 3. And so it's launching that next method call in the call stack trace. So as it's doing that, it's setting up the value of number for this local method. Remember, the value of number is whatever gets passed in as the argument. So number in this method call is 3. And now it's going to set temp equal to 1. And you can see that number equals 3. It's right here in the debugger. So it's helping us trace through that if we get confused. All right, so temp is equal to 1. Now it's going to print out in recursive call, number is currently 3. We can check that by flipping over to the console. It'll show us that. Yep, it's right there. Now we're going to check to see, is number less than or equal to 1? No, it's equal to 3. So we're going to go to the else block. Now it's going to calculate a new value for temp. It's going to be equal to number, which is 3, times the factorial of 2. Because number is 3, 3 minus 1 is 2, so it's making a new call to factorial. When we execute this line, it's going to go back up to that temp equals 1 message because we're making that new method call. And you can see the new number value is 2. We're going to add that to our call stack trace here as well. We called factorial using the value 2. So this one number is 2, and temp gets initialized to 1. And then we're going to execute through here. It's going to print out our recursive number. We can see that if we go over to the console. And then we're going to check to see if number is less than 1. It's not. We're going to go to the else block. We want to calculate a new value for temp. It's 2 times the factorial of 1, because 2 minus 1 is 1. And now when we step to the next line, it's going to go back up to the top of the factorial method because we just made a new method call, added yet another value to our call stack trace. Number is 1 and temp is 1. We're going to print out the message about the recursive call. You can see that if you go over to the console. And now we're checking to see, is number less than or equal to 1? In this case, it is. We're at the base case. So immediately when we execute this, it's going to return temp. So the current value of temp is 1. Let's trace that. Yep, it says temp equals 1, and it's going to return it. So next time when we step into the code, it's going to pop this value off the call stack because we've completed this call. As soon as you get to a return statement, that means you're done executing that method call. You're popping that off the stack, removing that record, you're done processing it. And again, you can tell that because you got to the return statement. So we're going to return temp, that's the value 1, and that value goes right here where we had made that recursive method call. Check that out. So the next line where it's picking up is the line where now temp is equal to 1 and number is equal to 2. So that's the current value of temp. And then it's going to, when we execute this line, fill in that value 1 that we got as the return value here, multiply it by 2, and it'll update the value of temp so it's 2. You can see that on the next line. It's down here in the output window. It also includes it right here. If we execute this line, it'll print the message to the console. You can see that here where temp is currently 2. That's the result of multiplying 2 times 1. And now we're done with this last line in the method where it says return the value of temp, which is 2. Remember, anytime you get to a return, that means you're going to complete this call on the call stack and remove it completely. The value that gets returned goes in exactly where you put the name of that method call in the previous call record. So we're returning the value 2. That's going to go right here in our previous method call. When you hit next, it jumps to that same line where it's processing that next statement in that previous call stack. So it's tracing through and it's going to calculate 3 times the value that just got returned, the 2. When you press next, it's going to show you that where it calculated temp is equal to 6 because that's 3 times 2. we got the 6 right here. And then it's going to print out the value of temp. It's currently 6. You can see that if you go over to the console window. And now we're ready to return that value temp. We're going to return the 6. When you get to the return, that's popping this off the call stack, and that return value 6 will get filled in right here where you had called the method. So it's going to pick up on that same line where we left off in the previous call. And so it's going to multiply together the value number, which is 4, times that previous, or the result of the method call that just returned, which was 6. So it's going to multiply those together, get the 24. We step through, it shows temp is equal to 24. We'll display that to the screen. We can see that if we go over to the console window. And then finally, it's going to return the value 24. Now, where's that return value going to go? We're popping that off the stack. That's going back to the original method call that was in the main program. So when we press next, it's going to go back up here to main. And it's going to show us that the value is 24. If we go over to the console, it's going to have printed that the factorial of 4 is 24. And so at this point, we're done with the main program. We're on the last line. And so the memory or the execution of the program is complete. So hopefully that gave you a little bit more insight about what's going on behind the scenes, how the recursive calls work. Remember that as you drop calls in, they sync to the bottom of the call stack. And then when you make a new recursive call, it kind of floats on top of that. You know that you get to the end of a method call when you get to one of these return statements that's part of your code. That means you need to pop that particular trace, that particular record off of the call stack, and then return to the previous version of it, filling in any value if needed.